In a fashion-conscious world, clothing defines the very nature of culture. But what is the nature of the clothing we wear?
I'm wearing a cotton.
For most of us, it's a mystery.
One piece is before napping, the other piece is after napping. So
These future fashionistas are hoping to shape American clothing trends. Behind every style is hard science. Now, a textile revolution is underway at this University of Nebraska chemistry lab.
We'll do a polyester dyeing today.
Ichi Yang teaches the science of textiles.
I'm a biochemical engineer, and what we do is develop bio-based materials for textiles and other industries.
Surprisingly, Yang's material of choice is not one you'd imagine. Yang believes that corn husks are the future for textiles.
If you look at history, textile is agriculture. In Nebraska, this is the place we have corn.
Corn, like cotton, is made of cellulose, the building blocks of plant cell walls. Globally, cotton is the most abundant natural fiber, while corn is the most plentiful grain. Using corn husks for textiles may become a necessity, as the world's soaring population competes with cotton and food for land.
If we use cultivated land to grow more fibers, we will have less land to grow food. We don't have the land to do both. So the best choice is to grow one plant for both uses.
Worldwide, our dependence on natural fibers has radically changed. In the 1960s, 80% of fibers were natural, and 20% were oil-based synthetics. But today, synthetics dominate the market. At the same time, the total demand for fibers has doubled in the last 15 years.
Next 10, 15 years, the consumption will double again. So everyone in the fiber business worry about where can we get that much fiber for the unlimited demands of humankind.
To address the problem, Yang's research team has created a test lab to process the corn husks.
We need to extract the fibers out from the husks.
Researchers add the husk to a tumbler reactor. Mixing organic chemicals and hot water, the tumbler decomposes the husks into coarse fibers. The fibers are then washed and refined and spun in a centrifuge. Finally, the fibers are dried and separated.
Fibers from corn husks have much better stretchability compared to any other natural cellulose fibers. That makes it useful to be compatible with other fibers.
So far, Yang's team has made one prototype sweater from a yarn of mixed corn husk and polyester fibers.
How does it feel?
Softer than linen, but still different from cotton.
But to make one sweater requires a single trash can of husks. To get the process to work on an industrial scale will require mass volumes of husks. Dave Nielsen is harvesting 2,000 acres of corn at his farm in Davie, Nebraska. He uses a combine routinely used by farmers across the U.S.
The corn is taken in through the corn head, and there's snap rolls on it that pull the stalk down through. The corn is shelled from the cob, and then the cob and the other residue runs through the combine and is thrown out the back end.
Normally, the farm waste is left to fertilize the land for the next growing season. Harvesting farm waste is a new idea and intriguing for Nielsen.
Anytime we can find new uses for our corn or our byproduct of our corn plant, that's great. The combine's set up to just harvest the corn grain. That's going to be the challenge. If you want to just use the husk for a clothing product or for fabric, how do you separate this husk from this stalk?
Most combines aren't able to separate the husks, so the best available option is harvesting them by hand. Unlike kernels and cobs, husks are ultra-light. A full barrel weighs just under 10 pounds. Yang's team needs 1,000 pounds to run a test to convince farmers, manufacturers, and mill operators that husks are worth harvesting on an industrial scale.
No, it's a challenge because there's not a market. There should be a need before a company can design equipment that way.
Ty and Jay Stukenholtz are ag engineers working on a sustainable harvesting solution to meet Yang's goals. They engineered this combine as a prototype to separate cobs as a source for biochemicals and biofuels.
Over the years, we use this machine to figure out how to clean the cobs and the shucks, basically the waste stream out of a combine.
Their combine separates the kernels and cobs, grinds the stalks as a mulch for the field, and ejects the husks out the back